Now let us see the last chapter of this course, that is Release 13 NB-IoT Air Interface. Uh, the few contents of this chapter are, are the same as EMTC. That is, first we will see the motivation of introduction of this NB1 or NB-IoT feature, and we will see the control channel operations as well as optimizations. Then proceeded with data channel operations as well as uh, optimizations, and we'll see the uplink and downlink HARQ processor similar to CATM1 or EMTC. And finally, we'll see coverage enhancement mode for the data channels and control channels as well as RAT channels. Motivation, again, the motivations remain same, but much more greedier than EMTC or CATM1. Again, to make the simplest device or cost, reduce the cost as much as possible and reduce the complexity as much as possible. Are the main motivations for NB-IoT to just build the simplest device that is possible by removing all the control channels and data channels overheads and reduce the operation as well for both control channel and data channels. Very low throughput is expected out of this thing that we have already seen. We are getting around some hundreds of kbps or sorry, maybe 1 kbps, a few kilobits of speed through this particular technique. And ultra low bandwidth will just utilize one PRB, that is around 180 kilohertz, and it is single RX, same as EMTC. And here it is mandatory half duplex, whereas in EMTC it is not mandatory. And here not even a single kind of mobility is expected. We actually expect the UE is very attached or completely non-mobile. And here we have even option of reutilizing the GSM spectrum, because GSM has 200 kilohertz bandwidth for per carrier, and we can reutilize the spectrum since we are going to just have one resource block or one physical resource block. Further extended coverage, uh, we have seen we through CATM1 we have achieved a few extended coverage through CE mode A and mode B. Um, Here the aim is to extend further and get the maximum sustainable coupling loss till 164 dB, and it is approximately 20 dB higher than CAT1 devices. And the main target is for deeper indoor coverage in industrial environments and underground establishments, very remote establishments, etc. And power saving remains same as we have seen before. The extended idle and content mode DRX. Even there is a provision to support the power saving mode PSM, that is releases 12 feature that we have seen before for NB-IoT devices. Since it is a single PRB based with and it has wider coverage, there are a lot of air interface changes that is needed for NB-IoT. We will see what are the air interface changes especially made for NB-IoT. Since it is just one PRB, we cannot reutilize any of the channel of LTE. All the channels of LTE cannot be utilized, whereas we have seen since CATM1 has 6 PRBs bandwidth, we could utilize few of the legacy channels such as PBCH, PRAT, PUSCH, etc. But since it is only 1 RB, we cannot utilize any of the channels, so none of the channel we can be reutilized. So all the channels has to be newly introduced for this 180 kilohertz spectrum again. So all these channels such as in PBCH, PDCH, PDCCH, PUSCH, PRAT are redefined again. Just the difference is they have added a suffix of n before, sorry, prefix of n before, and now the PBCH channel has become NPBCH channel here. Actually, the how this PBCH is actually done, I mean, maybe mapped is the broadcast channel transport block is actually mapped to 64 subframes within 640 milliseconds interval. The 640 milliseconds timing is actually blindly detected. There is no separate explicit signaling or separate space to detect the 640 milliseconds timing. It is blindly, the broadcast channel is blindly decoded. And the narrowband physical downlink shared channel carries the downlink shared information and paging information as well for NB-IoT UEs. The physical downlink control channel PDCCH informs the NB-IoT UE about the resource allocation of paging channel and DL shared channel. That is, we will get DCI information here in PDCCH, and even it carries the uplink scheduling grant for NB-IoT UE to transmit in uplink. The narrowband physical uplink shared channel NPUSCH carries the uplink shared information as well as hybrid ACNAC in response to the downlink transmission for NB-IoT UE. The key thing to note here is PUCCH channel is not being used here, as well as uh, PHIT channel and PCFIT channel, which are present in legacy, are also not being used. Even though we don't have those channels, we will be still able to proceed the communication here in NB-IoT. And narrowband physical random access channel, that is NPRACH, carries a random access preamble for NB-IoT PUE to the network or to latch onto the network. All these narrowband channels span over 180 kilohertz and are for CAT-M1 UA and CAT NB1 UAs only, and it is not backward compatible with LTE. Now we will see what are all the things that are not supported in LTE in NB1 when compared to LTE. Anything fancy is not supported in NB-IoT, since our aim is to make lesser and lesser complex and lesser costly modem for IoT devices. All these features that are described here, that is inter-rat mobility, not supported. Even handover is not supported because we expect the IoT UE is not mobile. Measurement report, CSI, even channel state indication is also not supported. Public warning functions is not supported. Real-time services such as voice over LTE or whatever it is multimedia based supported, etc. is not supported. Hybrid NBs, relaying, MBT, carrier aggregation, dual connectivity, nothing is supported. Fancy interference cancellation techniques such as NAICS, that is network assisted interference cancellation and suppression schemes, MBMS, interference for avoidance for in-device coexistence, etc. etc. Anything fancy is not supported. Even the RAN assisted WLAN internetworking is not supported. Anything side link communication, discovery, etc. is not supported. Emergency and even circuit switching fallback is also not supported because this is especially designed for communication between machines. None of the voice related services is also not supported. NB-IoT devices are, as discussed, targeted for low-end, mainly stationary applications, so many of the legacy features are discarded here.